Okay, hi everyone. I'm Tiffany. I'm a grad student at UC Santa Cruz. And last year at the Galaxy Workshop, I talked about a survey I was leading to identify new low-metallicity galaxies in our local universe. And so today I will be talking about the results of that survey. And all of this work is done in collaboration with Ryan Cook at Durham X and Mike Bolte. So first, a bit of background on my survey. So we are aiming to identify new low-metallicity galaxies in our local universe, particularly ones with gas phase oxygen abundances of less than or equal to a 10th solar metallicity. We'd like to push on the lowest metallicity regime, where we currently only have a handful of systems, such as Leo P over here, where their metallicities are about 300th solar metallicity. And our survey focuses on nearby blue compact dwarf galaxies because their active or recent star formation makes them easily observable. And so blue compact dwarf galaxies in our local universe are useful because their proximity means we can conduct detailed studies of their physical conditions. That means we can have better understandings of metal pore environments. We can understand how star formation and subsequent chemical evolution occurs at metal pore environments, and they're also useful for measurements of the primordial helium abundance, which was our initial motivation behind our survey. So our program aims to increase the sample size of low metallicity systems through SDSS photometry. So if you look at this U minus G versus G minus R color space, our survey queries this rectangle in the lower left of the plot. So our systems are very blue. And so the colors are similar to that of Leo P and currently known low metallicity systems. And from that selection criteria, we have currently observed 158 candidate systems. Our initial observations are done using the CAS spectrograph at LIC, and we've done follow-up spectroscopy with LRES for a subset of our systems. And so here are what some of our candidate BCDs look like in SDSS imaging. These three in particular are some of our lowest metallicity systems identified from the survey. And so on to some of our results. So we've confirmed about 100 new systems, and I'm showing them here on this luminosity metallicity plot. So they're shown with a sample of blue diffuse dwarfs, known XMPs, and some regular star-forming dwarf galaxies. So our observations are shown with the stars, with the light purple being systems we observed on CAS. So we're only able to make a estimate of the metallicity using the RNS calibration methods. And then the dark purple points are objects we observed using LRES, where we have a detection of the 4363 oxygen line for direct abundance measurements. So if we look at what defines the low metallicity system, so a 12 plus log OH value of 7.65, our survey has been pretty successful in identifying new low metallicity systems. Almost half of our 100 systems are less than or equal to 1/10 solar metallicity. And so I want to focus your attention to this object down here, the Little Cub, which is what we've named it. So Little Cub is one of the lowest metallicity star-forming galaxies currently known, and it was selected as part of our SDSS query through its photometry alone. And we've named it such because it's in the constellation of Ursa Major, so it's somewhere in this image. I'll give you a hint. It's right here. This little blue speck right there, if you can see it. So if you keep zooming in SDSS, this is what the Little Cub looks like, which is not that exciting, but this is the LRES spectrum of the Little Cub. So you can see our detection of the 4363 line here. So we've designed all our LRES observations so that we could get a pretty confident detection of that line for a direct oxygen abundance. And from the spectrum, we measure the Little Cub to have a 12 plus log OH value of 7.13. This is about 300ths times the solar metallicity. It's at a redshift of 0.003, and using two separate models for the local velocity flow, we estimate it to be at about 16 to 20.5 megaparsecs away. It has a star formation rate estimated to be 0.6 to 1.1 times 10 to the -3 solar masses per year. And so just in terms of our initial survey goals, which is to identify new low metallicity systems through photometry, the discovery of the Little Cub in itself was pretty exciting to us. But if we go back to the SDSS image and look at this field in H1 gas, this is data from the Westerbork Synthesis Radio Telescope. We find that the Little Cub is extremely gas-rich, so it has a H1 gas mass of about 5 to 8 times 10 to the 9 solar masses, and we also estimate it to have a stellar mass of 10 to the 5 to 10 to the 6 solar masses. And we think that it's also interesting because there seems to be an extended gas tail around the Little Cub extending towards this nearby spiral galaxy, which is NGC 3359. So there are no accurate distance measurements to either of these systems, but a separate work by Tully et al. In 2013 estimated the distance to NGC 3359 to be about 20.8 megaparsecs, which is consistent with one of our distance estimates to the Little Cub. The two systems have a velocity offset of 53 kilometers per second, which we think is a strong suggestion that they might be interacting. And if they are, their separation in the sky puts them at a distance of 70 to 90 kiloparsecs away from one another. So in the context of our own local group, it is rare to find such low mass and gas-rich satellites around large spiral galaxies. We've had some talks this past week about how the local group might not be typical in its satellite population, though. So, and the local group satellite population is in contrast isolated dwarf galaxies, which are almost always actively star forming and gas rich. And so we think that if the Little Cub and NGC 3359 are interacting, this would be a very unique system to study the process of satellite quenching and how dwarf satellites evolve. So in summary, we've designed a new survey to identify new low metallicity systems based on photometry alone. We have observed 158 candidate systems, and we report the discovery of 100 new systems, with almost half of them having less than or equal to 1/10 solar metallicity. We also report the discovery of the Little Cub, which is one of the most metal-poor star-forming galaxies currently known, and we hope that we can extend our survey to volumes beyond the local universe and to look into all-sky surveys outside of SDSS. Thank you.
So, are you using surface brightness to select the sample? And in this case, what is the surface brightness of this object?
We do not use surface brightness to select our sample. We just pick it based on color alone. But we do look at, so the query returned like 2,000 objects, so we looked at them individually, and we did kind of by eye select by like what they look like morphologically, and we also like eliminated objects that look like H2 regions in larger galaxies and stuff like that, but not like by surface. Yeah, exactly. So it's some of them, we look for like bright knots, which we think is indicative of the active star formation and the low metallicity region, and then some of them have like fluffy tail-like surroundings. Yeah. David? The surface brightness? The effective brightness?
Effective radius.
Oh, effective radius. So how large we think it is? I don't actually think we've looked into that. Good. David?
Notice your spectrum showed that the H beta line was stronger than the oxygen free.
Yeah.
It's very, very rare.
Yeah, so usually it's
less than a handful. So how many of your other candidates are in that category?
yes, I think this one's the only one where H beta is brighter, but it has a really strong O2 line. Yeah.